Section 5.3, here we discuss 5.3, 5.4, and 5.5. 5.3 is talking about the formula that we mentioned before at 5.2, that if you have a log with a different base, if the base is not 10, you could always write it as log over log. So if I have log of 7 with the base of 3, you want to calculate that, you write it as log of 7 divided by log of 3, which both have base of 10. So you use your calculator, you find log of 7, you find log of 3, and then you divide these two. And he showed you the example, log of 25 with base of 4 is log of 25 over log of 4. So you use your calculator, you estimate each of this, and then divide to find that number. There are some formulas for the log that you need to remember, and when you want to work on the problems, it's better to have a copy of this page with you so you could find the correct, proper formula for that problem. One is log of multiplication is log of summation. This is how to expand a log. Okay, so log of u times v is log of u plus log of v. Also true for the natural log. All the formula for log also apply to ln. There is no difference. It's just this is log, this is ln. Log of fractions, if you want to expand log of fraction is log of numerator divided by log of denominator. The other one is the power property, that if you have an exponent, you could always transfer exponent to the front. This one is important because for you to use any of this formula, you're not supposed to have any number before the log. Okay, so here, for instance, what is log of, let's say instead of 6, you write 2 times 3. Now, if you want to expand this, log of multiplication is log of summation. Log of 2 times 3 is log of 2 plus log of 3. Or log of fractions is log of numerator minus log of denominator. And then 27 is 3 to the power of 3. And then 3, you could always bring it to the front according to this law. You could always bring the power to the front of the log. There is another formula that if you have a radical and you want to pull a number out of the radical, you write it as, you write the base and n divided by m. For instance, if I have cubic root of 5 or 5 to the power of 1, if you want to remove 5 from the radical and write the exponential, you write the base and then it's 1 over 3. And then here is another examples. Log of multiplication. 5 times x, 3 times y. See, there are 3 of them. When you want to expand it, is log of 5 plus log of x3 plus log of y. And then this 3 is the power can always come to the front. Again, this part, which you go from here to here, is based on this formula. Anytime you have a power, this power can come to the front of the log. So in that case, this 3 would come to the front of the log. This is log of fractions. Log of fractions is log of numerator minus log of denominator. So here, log of numerator minus log of denominator, you put it here. And then half again comes to the front of the log. Now this is, you want to do the opposite of that, means now you want to combine some logs into one, okay? So here you have log of summations, but I cannot use the formula. Why not? Because there is a number before. Look, log of summations, if you want to go from this side to the other side, means if you want to combine this into multiplications, you should not have any number before the log. See, all this formula, these two, they don't have any number before the log. So if there is a number before the log, you have to use this formula. And if there is a number, bring that number back and make it as a power. See, you could either bring it like this, or if there is a number here, you could bring it back here and make it power. So in that case here, I bring this half, make it power, x to the power of half. I bring this 3 and make it as a power here. Now log of u plus log of v is log of uv, log of multiplications. The same thing here. I want to use log of u minus log of v, but I have to move this number to the power first. So I bring this, make it as a power here. Then log of u minus log of v is log of fractions, which is log of numerator divided by denominator, okay? Log of subtractions, if you want to go from this side to that side. Log of subtractions, if you want to combine into one log, is log of fractions. Log of u minus log of v is log of uv. Log of u minus log of v is log of u over v. This is how to combine two log into one log, but it as a fraction because it was subtractions, okay? And now there are some homework here, which basically we are using two formulas. One is if you have a log of a with any base, you could write it as 2 log. We already discussed that. Or if you have a number, you could always bring it to the front. So 128, first I break 128 into 2 to the power of 7. 32 also is 2 to the power of 5th. So you break 32 to 2 to the power of 5th, you break 128 to 2 to the power of 7. These two would both exponent come to the front. Log and log cancel, so it's 7 over 5. You could do it this way, or you could just go ahead and use this formula and write this as log of 128 over log of 32. And when you use your calculator, that gives you this, but it would give like a decimal number. And these are, you kind of explain all this here. You need to remember, log of a number, this number always has to be positive. You remember talking about the domain? The number after the log has to be positive. If I use my calculator and type log of -6, calculator will give me an error. So after the log, you cannot have the negative number. Natural log of e. Why natural log of e is 1? Because base also is e. Okay. So I want to go over these problems quick because this one, if we are using this formula, we bring the 2 down here. We are using this formula, log of multiplication is equal to log of summations. So we split this into natural log of z plus natural log of z, and then you bring the 8 here. Log of fraction is equal to log of subtractions, and this is a fractions. So it would be log of numerator minus log of denominator. The numerator is x3, denominator is that. And then this one, you could also expand it. Because this is log of multiplication, you could write it as log of summation, but make sure you put a parenthesis, and after you expand it, then they bring in negative and multiply. So for me to use the formula, I should not have any number. So first I bring all these 3 and 6 and make it as a power. And then I use the formula, okay? So that brings us to section 5.4. Again, 5.4. We discussed already that if you have two functions equal, if the bases are equal, you could put the exponent equal to each other. See here? The base is e, so then numerators are, the power are equal, so you solve it. First, I bring 4 to that side to make it 15. Divide both sides by 2. Now, this part, one of the advantage of the log, let me show you the example. Let's say you want to solve this problem. 3 to power of x is equal to 9. This one is obvious what the value of x is, because you could write 9 as 3 to power of 2, right? Then you say 3 to power of which number is 9? Is 2. So x is 2. What if you say 3 to power of x equal to 7? Can you find the number that when you take 3 and raise it to that number is 7? No, it's not easy because it's a decimal number. In this case, you have a choice. You could take ln on both sides, natural log, or put log on each side. It doesn't make any difference. So what you do is you put a log on each side. What log does, it helps you to bring the exponent to the front, according to that formula that we show you, that if you have a power, you could always bring the power to the front. So then would be x natural log of 3 is equal to natural log of 7. And then all I need to do is divide both sides by natural log of 3 to find the x, and always give you a negative number when you divide. So you go on your calculator, you find natural log of 7. And divide by natural log of 3. See, natural log of 3 divided by natural log of 7. A 1.77, okay? That's why you couldn't find it. What number? 3 to power of 1.77, they almost give you 7. So anytime you have x as a power or any type of variable as exponent, by solving the log, we could bring the power to the front. It doesn't matter whether you use log or you use ln, either one, you come with the same answers. Okay, so here in these problems, we did all this first, and now we put the log on this side and log on that side. Then the power is 2t minus 5. The whole t3 minus 5 come to the front. Okay, so right there, I'll show you this part. It's, you have log of 3 to power of, let's say 2x instead of 3, equal to log of 15.5. Let's say 7.5, for instance, okay? This power would come to the front. So you have 2x minus 5. Log of 3 with base of 3 is log of 7.5. This cancel because log of 3 with base of 3 is log of 3 over log of 3, which cancel both is 1. So all you have is 2x minus 5 is equal to what? Log of this. You could use the calculator and find that number if you want. Log of 7.5 is log of 7.5 is like 0.875. And then you bring 5 to that side. So 2x is 5.875. And then divide both sides by 2. That gives you the value of x that they have here, which is 3.417. Okay, so that would be 3.147. That's how to find the value of x. Now, the homework problems in the beginning, this is easy to find because both bases are equal. So these two are equal. Remember, one of the property of the log is if you want to get rid of log, what you have after the log, you write this and then 2 to power of that. This is another problem that, 6 to power of x equals 7,776. You could either do it this way. This is one way to do it using this formula, okay? Or what you could do, another way to do this problem is this. 6 to power of x is 7776, right? You put the LOG on this side or LOG on that side. This x come to the front. Then you have x log of 6 is equal to log of that number, right? And then to find the x, you divide both sides by log of 6. So the value of x is log of that divided by log of 6. So you use your calculator, you find this, you find that, divide. That should give you the number that they have here, which is 5, okay? I'll put a formula. First, you write it as log of fractions. So log of x minus log of 10 is log of x over 10. And then to get rid of this, instead of 0, if you take this e and raise it to power of 0 is 1. I'll show you this in this part because it wasn't very clear. So x is 10. I think these problems, I have the solution for you here. They all use the same format. Look, why do I use ln instead of log? Because I see a e. When you see a e, it's better to use ln. So again, first I bring the 4 to that side, make it 23. If you put ln on each side, then you could bring the x to the front. You are using these problems, this idea here too. If I don't see any e here, I'll just put log. I put the log on each side, bring the 5x to the front, and so on. So these problems are all very similar. I want to skip this ones. You put the log on each side, power come to the front. And for the graph, the last part, which is calculations, again, they want you to find the x. I put the ln on each side, bring this to the front. So that brings us to section 5.5. 5.5, there are 1, 2, 3, 4, 5, 6 formulas. Each has a name, like exponential growth model is this, decay model is that, and so on. And then they are using these for the problem. For instance, for the very first examples they have here, amount of S is spent in the United States on mobile online advertising is this formula is given. S is equal to that. And T is always between 10 and 14. What they're saying is, go ahead and take these numbers. T equal 10, T equal 11, T equal 12, T equal 13 and 14, and put it into this T and calculate the S. Those numbers must be here, model. This is the one that advertising is spending shows, but this is what the model tell you. Means by taking the numbers and substitute here, this model would give you these numbers. And I'll show you here. This page was not on your copy. So for instance, for T equal 10, you put 10 here, e to power of that. You use e to the x on your calculator, you find these numbers, multiply by that, that gives you almost 0.7. And that's the 0.7 that you see here for the model. I also calculate for T equal 11. So T equal 11, you put it here, and it should almost give you 1.5. So you just need a more calculation for these sections, how to do the calculations, okay? Again, model for T equal 11, model give you 1.5, right? So the model for 2011 or for T11 give you 1.5. Now, what you have here is, now what if we give you the value of S, which is 65, and he asks you to find the T? How would I calculate that? So what you need to do is, first you divide both sides by 0.0036, 65 divided by that number is this. Then you put an ln on each side, bring the whole power to the front, and then natural log of e is 1. So this part, I can show it here. Natural log of e to power of 0.7563t is natural log of 18556. Sorry. And then the whole thing comes to the front. And what is natural log of e is 1. And then this part is what you see here. Natural log of 180 and so on is 12.1. And then divide both sides by 0.7536. T is almost 16. So in this one, they're asking us to use modeling population growth, which in this page, law of exponential growth is this formula. Okay? We are using this formula, and y is 100 when t is 2. So you put, this should be t here, so you understand it. Is x, but in this problem we are using t. So y is a e to power of bt. So they are saying when t is 2, y is 100. When t is 4, y is 300. So we have two equations here. If you divide these two, if you take this, the whole thing, and divide by that, it gives you this. So you take these two and divide. Or what they, in this one, what they do, they just find the a from this equation and substitute for a into other one. This is another way to do it. So what you could do here is, another way to do it is this. Look, let's say you have a e for b equal to 300. This is one equation. And we have a e to b equal 100, another one. If you divide these two, a and a cancel, this one is e to power of 2b equal to 3. This is another way to do it, to solve it. So then I'll put the ln on each side and bring the 2b to the front. 2b natural log of e is natural log of 3. This is 1. So 2b is natural log of 3. And b is natural log of 3 over 2. That's another way to do this problem. And when you find a b, then you could take one of these equations, like e to power of a e to power of 2b equal to 100, right? So a times e to power of 2 times natural log of 3 over 2 is 100. This is equation that 2 and 2 cancel. So it's a e to power of natural 3 is 100, right? So to find the e by itself, e is 100 over e to power of natural log of 3. You could find the calculator, you could find these. You could find the natural log of 3, take e and raise it to that, 100, divide that, give you the value of a. This is another way to do the problems. You could pause the video and copy this if you want to use this solution for these examples. And then there is an example here, which I mentioned. You look at the homework number 5. Carbon dating model. This formula is given. In this example, they're telling you that instead of the R, just substitute 1 over 10 to power of 13. 10 to power of 2, 10 to power of 13 cancel. That would just leave it E. Again, to move the power to the front, you put a natural log on each side, bring that to the front, and then that would calculate the E. And there was another one. This is in this problems, in this example, they're using logistic growth model, this model. So this is given in the problems. Okay. In the beginning, they are just asking you for put T5 here into this equation. These are all just hand calculation that you need to use the calculator to do all this. Second part, what if we give you the y value and ask you to find the t? So you need to do a cross multiplications here. All right, so now I'll go over the example. For the first one, I show the solution here that all are using the formula. And they're saying that we here determine the time necessary for P dollars to double. Means instead of P, you have 2P now. You put $10, you have 20. You put $40, you have $80. So P, 2P, P and P cancel. So it's always 2 to 1. It's always 2 to 1. How do I bring the power to the front? Put the log on each side and then move n to the front. Okay. And then different case. When it's monthly, then you put 12. When it's daily, you use 365. They do it 365 times in a year. There are 365 days in a year. So if it's continuous, then you have a different formula. This is for continuously. Still is 2 to 1. You just need the R, which is 13% and so on. All right, so exponential decay model. In this one, whatever you start, the other part is always half of this. If I start with 9 grams, then I have 4.5 here. If I put 20, then it's 10. So the ratio is always 1 to 0.5, 1 to 0.5, or 1 to half, 1 to half. See, that's why you have half here. The ratio is always 1 to 0.5, or 1 to half. How do I bring the power to the front? Putting ln on each, then the whole thing moves to the front. Natural log of E is always 1, so that is gone. To find B by itself, you divide both sides by 1959. This problem, right after you find the B, you take the B and you put it into original equations. So now is A e to power of this B and T are given. That helps you to calculate the Y value. And the next problem is very similar, to use this exponential decay model. Number 4, they're asking you to use, for problem number 4, they're asking you to use this formula. And each time, from 1980 to 1980, T equals, you put T equals 0 here. When you put 0 here, e to power of what? 0 times any number is always 0. What is e to power of 0? 1. So all you need to do is add these two. Then T equal to 10, you put 10 here, and so on. Part B, this value is given. They want you to calculate the T. So first I subtract 17.5 from 360, divide by 80.6. Now to bring this power, again, you take the natural log of both sides, and that bring, see, natural log of E is 1. And you calculate the T. And again, law of exponential growth is that. And in this problem, Y is given, B is given. So you go ahead and calculate. It's very similar to the other, I think, problem number 2 that we did. You could use this. Find the T, and then when you find the T, then you put it back into these equations. You have the T, you have this one, and you want to find the A value. Okay, so that would be end of these sections.